Welcome back. In the last video, we covered a little bit about tensor data types, as well as some of the most common parameters you'll see passed to the torch.tensor method. And so I issued you the challenge at the end of the last video to create some of your own tensors of different data types, and then to see what happens when you multiply a float 16 tensor by a float 32 tensor. Oh, it works. But you're like, Daniel, you said that you're going to have tensors not in the right data type. Well, this is another kind of gotcha or caveat of PyTorch and deep learning in general, is that sometimes you'll find that even if you think something may error because these two tensors are different data types, it actually results in no error. But then sometimes you'll have other operations that you do, especially training large neural networks, where you'll get data type issues. The important thing is to just be aware of the fact that some operations will run an error when your tensors are not in the right data type. So let's try another type. Maybe we try a 32-bit integer. So torch.int32, and we try to multiply that by a float. Wonder what will happen then. So let's go int32. Int32 tensor equals torch.tensor, and we'll just make it 3. Notice that there's no floats there, or no dot points to make it a float. 369, and d type can be torch int32. And then int32 tensor, what does this look like? Typo, of course, one of many. Int32 tensor. So now let's go float 32 tensor and see what happens. Can we get PyTorch to throw an error? Int32 tensor. Huh, it worked as well. Or maybe we go int64. What happens here? It still works. Now see, this is again one of the confusing parts of doing tensor operations. What if we do a long tensor? Torch.long. Is this going to still work? Ah, Torch has no attribute called long. That's not a data type issue. I think it's long tensor. Long tensor. Does this work? D type must be torch D type. Torch long tensor. I could have sworn that this was torch.tensor. Oh, there we go. Torch.long tensor. That's another word for 64-bit. So what is this saying? CPU tensor. Okay, let's see. This is some troubleshooting on the fly here. Then we multiply it. This is a float 32 times a long. It works. Okay, so it's actually a bit more robust than what I thought it was. But just keep this in mind when we're training models. We're probably going to run into some errors at some point of our tensors not being the right data type. And if PyTorch throws us an error saying your tensors are in the wrong data type, well, at least we know now how to change that data type or how to set the data type if we need to. And so with that being said, let's just formalize what we've been doing a fair bit already, and that's getting information from tensors. So the 3 big things that we'll want to get from our tensors, in line with the 3 big errors that we're going to face in neural networks and deep learning, is, let's copy these down. Just going to get this. Copy this down below. So if we want to get some information from tensors, how do we check the shape? How do we check the data type? How do we check the device? So let's write that down. So to get information from this, to get D type, or let's write data type from a tensor, can use tensor.dtype, and let's go here. To get shape from a tensor, can use tensor.shape, and to get device from a tensor, which device is it on, CPU or GPU, can use tensor.device. Let's see these 3 in action. So if we run into one of the 3 big problems in deep learning and neural networks in general, especially with PyTorch, tensor's not the right data type, tensor's not the right shape, or tensor's not on the right device, let's create a tensor and try these 3 out. We've got some tensor equals torch.rand, and we'll create it of 3, 4. Let's have a look at what it looks like. There we go. Random numbers of shape 3 and 4. Now let's find out some details about it. Find out details about some tensor. So we'll print some tensor, and oops, didn't want that. Print, and let's format it or make an F string of shape of tensor. Oh, let's do data type first. We'll follow that order. Data type of tensor, and we're going to go, how do we do this? Some tensor dot what? Dot D type. Beautiful. And then we're going to print tensor's not in the right shape. So let's go shape of tensor equals some tensor dot shape. Oh, I went a bit too fast, but we could also use size. Let's just confirm that actually. We'll code that out together. From my experience, some tensor dot size and some tensor dot shape result in the same thing. Is that true? Oh, function. Oh, that's what it is. Some tensor dot size is a function, not an attribute. There we go. Which one should you use? For me, I'm probably more used to using shape. You may come across dot size as well, but just realize that they do quite the same thing, except one's a function and one's an attribute. An attribute is written dot shape without the curly brackets. A function or a method is with the brackets at the end. So that's the difference between, these are attributes here. D type, size, we're going to change this to shape. Tensor attributes, this is what we're getting. I should probably write that down. This is tensor attributes. That's the formal name for these things. And then finally, what else do we want? Tensors, what device are we looking for? Let's get rid of this, and then print f device tensor is on. By default, our tensor is on the CPU. So some tensor dot device. There we go. So now we've got our tensor here, some tensor. The data type is a torch float 32 because we didn't change it to anything else, and torch float 32 is the default. The shape is 3,4, which makes a lot of sense because we passed in 3,4 here. And the device tensor is on is the CPU, which is of course the default, unless we explicitly say to put it on another device. All of the tensors that we create will default to being on the CPU rather than the GPU. And we'll see later on how to put tensors and other things in Torch onto a GPU. But with that being said, give it a shot, create your own tensor, get some information from that tensor, and see if you can change these around. So see if you could create a random tensor, but instead of float 32, it's of float 16. And then probably another extracurricular, we haven't covered this yet, but see how to change the device a PyTorch tensor is on. Give that a crack, and I'll see you in the next video.